All right, so now we're working on this next problem, number 2, and we see that we have got mass M and then mass M. Notice that the M's are the same, and this is block A and that's block B. They're connected by this string that is a total of 4H. And basically, they give us all these distances, and the important part here is express all algebraic answers in terms of H, M, and G. So there's not really anything else that we can use except for that. So first part is determine the acceleration of the block as it descends. So this is going to be a sum of the forces problem, okay, because that's how we're going to be able to find this. So, and we see this as it descends, that means it goes down. So our acceleration is going to the right over here and down over here. And so let's just draw our free body diagram. So we've got this mass A, this is mass A, and we've got our normal going up, our mg going down, and our tension going to the right. We can just call this mg because they just call it m up there. And our acceleration is going to the right like that. And then for this other block, we've got our tension going up and our mg going down, and this time our acceleration is going down. So let's look at the sum of the forces equals, and we are doing the sum of the forces for the entire system. And so if we do that, we're going to have to say m plus m, because that's mass total. All right, this m, and this m, and it looks like they're the same. All right, and then times acceleration is equal to, we see the first force we can deal with right here is our mg, so we're going to say mg, and it's positive because it's going the same direction. This is going the same direction as this acceleration right here. Then we've got our t, which is going the opposite direction, so it's minus t. Then over here, the tension's going the same direction, so it's plus t. These end up canceling out. So you're going to get 2ma equals mg, oh, we've got m on both sides, so we can cancel those out. Divide both sides by 2, because we're looking for a. We get a equals g divided by 2. All right. So, block B strikes the floor and does not bounce. Determine the time t which block B strikes the floor. So, this is just a kinematics problem again. Or not again, but this is a kinematics problem. And so we are just looking for the time. All right, we know our change in y. Our change in y we see is going to be this h. So change in y equals h. We know that this block is accelerating at the same acceleration, g over 2. So we've got our acceleration, which is g divided by 2. They also say in here that block B is released from rest. Therefore, our initial velocity must equal 0 meters per second. All right, so using these variables right here, we can now go ahead and find this time. So let's use our equation. Change in y equals v naught t plus 1/2 at squared. Cross out our v naught. So then change in y equals 1/2 at squared. Now we can multiply 2 by both sides, get rid of the 1/2. So we get 2 change in y equals at squared. Divide both sides by a. Square root both sides, because we've got a square right there. So t is going to equal square root of 2 change in y all over a. But we can't use change in y, we can't use a. But we already know that those, those are equal to h and g over 2. So we're going to plug that in, so we get square root of 2 times h divided by g divided by 2. And so we can bring this 2 up there, and so we end up with t equals the square root of 4h all over g. We can simplify this a little bit more. We can bring this 4 out and say the square root of 4 times the square root of h over g. And we end up with t equaling 2 times the square root of h all over g. So that's the time that it takes for this block to go down, for it to hit the ground right there. So then our next question asks us to describe the motion of block A from the time t until the block hits the floor. So basically, it's just asking us, so until this block hits the floor, what is this block doing? And we know, just from what we know about forces and about systems, this block is accelerating at the same acceleration as this block right here until it hits the floor, and then it's going to do something else. And we'll talk about that in just a minute. So to answer this is just accelerating A equals G all over 2. All right, now, but what about the motion of the block from the time the block B strikes the floor to the time block A leaves the table? So basically, what's going on here is we have got block B right here. It's already hit the floor, and block A is just zooming right along. But look, once this block B has hit the floor, we no longer have anything pulling this towards it. So that is no longer, we no longer have that. Therefore, the forces are going to be balanced. And if the forces are balanced, then our velocity is constant. All right? Whereas over here, our forces were unbalanced because we had this block descending to the ground. So when this block was descending to the ground, it was pulling this block, making this block accelerate. But now, in this case, this block is no longer pulling this block. So this block is just going at a constant velocity. So this next one is kind of a long part, so we're going to do this in a second part of a second video.